Okay, let's look at the next example. Okay, we're going to continue graphing two periods. Of each function. Okay, and we're going to start with y equals 2 sine x. Okay, so that's what we just graphed in the last example. This time we're going to add this plus 1 on here. Okay, so my amplitude is 2, right? We found that in the last example. My period is still 2 pi. Okay, but this time I've got this vertical translation. Okay, I've got this vertical translation of 1 unit. All right. Okay, so my critical points are going to stay the same. Remember, if I take my period, I'll come down here and do this. If I take my period and I divide it by 4, okay, that means that each one of those intervals is going to be pi over 2. Okay, and I'm not going to take the time to figure each one of these out since we just did it in the last example.
This week, high profile.
Okay, and it's going to be the same on the negative axis, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. Okay, my amplitude is still 2. All right, okay, so here's all this. Now, this is where things are going to get a little different. Okay, so far we've been going from the x-axis, but if we have a vertical translation of 1, that shifts everything up 1 unit, including the x-axis. Okay, so now we're not necessarily going from the x-axis anymore. We're going from the horizontal line that crosses the y-axis at 1. Okay, so my x-axis technically gets shifted up 1 unit. Okay, and really, this is called the midline. It's the line that goes through the middle of the graph. So far, the x-axis has been our midline, and I just haven't been calling it that. Okay, but now that we have to graph with these vertical translations, okay, I'm going to start calling it our midline. Okay, so now, instead of our midline being the x-axis, which is y equals 0, our midline is y equals 1. Okay, it shifts up. Okay, now let's think about the definition of amplitude. Okay, so amplitude is the height of half the graph. That means that half of the graph is 2 units high, okay, and 2 units, well, 2 units in both directions. Okay, so my amplitude here, yes, it's still 2, but amplitude is really just distance. Okay, so that means when I'm graphing the sine function, I'm now, instead of starting at the x-axis, I'm starting at the midline, okay, which is at 0, or I'm sorry, which is on the line y equals 1. I'm going up to my max. I have a new max. Okay, my max is now 3. It's not 2 because it's 2 units above the midline. Okay, then I go back to the midline. Then I go to my min. My min is 2 units below the midline. Okay, that's the definition of amplitude. So my graph is 2 units above the midline and 2 units below the midline. And then I go back to the midline. Okay, so this graph, right, it looks the same as the one we did in the last example. It's just shifted up 1 unit. And then I can go back the other way. So midline, I'm going down to my min, which is 2 units below, back to my midline, up to my max, midline. Okay, and there is my graph. Okay, let's look at graphing y equals 2 minus sine of 2 pi x divided by 3. Okay, so if I write this like we were yesterday in standard form, I'm going to leave this as negative sign. Okay, technically I'm factoring out 2 pi over 3 here, plus 2. Okay, putting this 2 right here is the same thing as adding it on the end. Okay, and then we can go back and look at our letters from yesterday. Right, here's my A. Here's my B. Okay, H, right, is technically 0. We're not looking at a phase shift yet. And K is that vertical translation, which is 2. Okay, so I have an amplitude. Remember, it's the absolute value of this number, so my amplitude is 1. Okay, that means my graph goes 1 unit above the midline and 1 unit below the midline. Okay, my period is 2 pi. Okay, so I have 2 pi times 3 over 2 pi. If I multiply those together, that gives me 3. So my period is 3. Okay, so this is getting a little more challenging here. If I want to find out the length of between my critical points, I take my period and I divide by 4. Okay, so the distance between each one of those critical points is going to be 3/4. Okay, and then I have a vertical translation. Right, of up 2. Okay, so I have a lot going on here. All right, so let's draw out this graph. If I start at the 0, at 0, one full cycle of my graph is going to end at 3. Okay, so if I start at 0 and I lay out, I break it into quarters. Okay, each one of those intervals is 3/4 of a unit. So if I start at 0, this would be 3/4, and then I add 3/4 plus 3/4, right, is 6/4, and I'm going to come back and reduce this in a minute. And 6/4 plus 3/4 is 9/4. And 9/4 plus 3/4, right, I'm just going to write this down right here, is 12/4. Okay, so if I go back and reduce, right, 6/4 is going to reduce to 3/2. And 12/4 reduces to 3. Okay, so that all works out nice and neat. Same thing in the opposite direction. So I have negative 3/4, negative 3/2, negative 9/4. Okay, I've got this vertical translation up 2. Okay, I've got this vertical translation up 2, which means my midline, okay, which we've been using as our x-axis, or we've been using the x-axis as the midline, now goes up to y equals 2. Okay, so that means our midline now is at y equals 2. Okay, my amplitude is 1. That means that my graph goes 1 unit above the midline and 1 unit below the midline, okay, when I graph. Okay, so the last thing we need to look at is this negative sign. Okay, is this negative sign? So usually when I graph sign, if I start at 0, right, I go up to the max, to the midline, down to the min, to the midline. However, this is a reflection across the x-axis, so that changes it. Okay, so if I start at 0, I'm going down to the midline, or I'm sorry, down to my min, up to my midline, up to the max, which is 1 unit above that midline, and back to the midline. Okay, so that function looks like this. Okay, and then the same thing in the negative direction. I'm at the midline. I'm going up to the max, to the midline, down to the min, to the midline. Okay, and there is my sine function.